Sorry guys, my webcam was out of battery, so I just put another one. Now let's continue where we left over. We applying the lock on both sides. In this problem, I apply ln, means lock base on both sides, and it allows me to bring the exponent down in front. Now what you've seen here is actually a linear equation, okay? ln of 2 and ln of 3 are just decimal numbers. So I distribute that ln into the two terms. I got ln of 2 minus x ln of 2 equal to 4x ln of 3 plus 6 ln of 3. Now what I'm going to do is, to solve this linear equation, I'm going to put all the terms with x on one side and leave all the terms without the x on the other side. So let's do that. I'm going to add x ln of 2 on both sides. X ln of 2 on both sides. This is plus sign, alright? And then I'm going to subtract 6 ln of 3 on both sides. Minus 6 ln of 3. Another way, I try to bring all the terms with x to the right hand side. All the terms without x to the left hand side. So what you guys going to see here is going to be ln of 2 minus 6 ln of 3 will be equal to 4x ln of 3 plus x ln of 2. Now I'm going to factor out the x on the right hand side. X out as a common factor. We got 4 ln of 3 plus x ln of 2 equal to ln of 2 minus 6 ln of 3. Now what? Divide both sides by whatever you got on the exponent in the parenthesis, and you have this. ln of 2 minus 6 ln of 3 all over 4 ln of 3 plus, oh, there's no more x in here, plus ln of 2. That will be the answer. Okay? There's no x in here. I already factored out the x. Okay, let's try one more. This type. One more exercise of this type. Try another one. It's a little bit more complicated. Not too hard. Okay, let me find an example in the book. All right, how about 5 times 3 to the 2x plus 1 equal to 7 times 2 to the x minus 1. Okay. Don't take 5 times 3, okay? That won't work. That will be incorrect because 5 doesn't have any exponent in here. You can only multiply the base number as if they have the same exponent. Same reason. Don't take 7 times 2. It's not equal to 14 raised to the power. You have to leave it that way. And you see that x on the exponent. They ask you to solve x. You apply the log on both sides to bring the exponent down. Again, I'm going to do ln. ln of 5 times 3 to the 2x plus 1 going to be equal to ln of 7 times 2 to the x minus 1. Now, on the left hand side, I got the log of product two factors. So I can break it out as ln of 5 plus ln of 3 to the 2x plus 1. Same thing applied to the right hand side. We got ln of 7 plus ln of 2 to the x minus 1. Okay, so ln of 5 is good, ln of 7 is good. Now, I'm okay to bring the exponent down. We got ln of 5 plus 2x plus 1. ln of 3 equal to ln of 7 plus x minus 1 times ln of 2. Remember, we have a log exponential form inside. We are okay to bring the exponent down. Okay. Now, distribution. ln of 5 plus 2x, ln of 3 plus ln of 3 equal to ln of 7 plus x ln of 2 minus ln of 2. Okay? And I claim that this is no more than a linear equation. You want to solve x from here, you try to bring all the terms with x to one side, bring all the terms without x to the other side. Now this time, let me bring all the terms with x to the, say, to the left-hand side then. and bring all the term without x to the right. So I got 2x, ln of 3 on the left, right? Leave it there. X and a 2 on the right, minus, gonna bring back to the left. So what? Minus x, ln of 2 equal to, okay, that's all the terms got x, yes. Now on the right hand side, ln of 7 minus ln of 2. Now we have ln of 5 and ln of 3 on the left hand side. You want to bring to the right, just simply subtract those two. Ln of 5 and then minus ln of 3. They are to the right hand side. Now on the left, factor out the x. 2 ln of 3 minus ln of 2 equal to ln of 7 minus ln of 2 minus ln of 5 and minus ln of 3. You know what to do from here? You divide both sides by whatever you got in the parentheses. So x is equal to ln of 7 minus ln of 2 minus ln of 5 minus ln of 3 all over 2 ln of 3 minus ln of 2. And you have the answer. The reason why people usually prefer either log base E or log base 10, because if they want to convert to decimal solution, it's easier for you guys to plug in the calculator. So if this is the original solution, the exact solution, say if you like decimal, all you have to do is plug in your calculator, right? Hit ln 7 and minus ln 2 minus ln 5 minus ln 3 in parentheses, and then divide, open parentheses, 2 ln 3 minus ln 2. You have the answer without changing the base. ln is in your calculator. Okay? All right. I think that's pretty much enough for this type. Let me move on to another type of problem. Now you don't see a linear equation after simplify anymore. You're going to see a quadratic one. And in order to get a quadratic exponential equation, they have to set up with nice base, nice numbers, so that's going to work out. Okay, so let me have a problem. Okay, 2 raised to the 2x minus 4 times 2 to the x equal to 21. Again, they all solve for x, all right? So what we're going to do here, we're not going to apply the log of both sides, because if you have a log, you don't have a product yet. You have a difference of two terms. It's very hard for us to simplify. So the technique that we're going to apply in this problem is apply a substitution. We let u equal to 2 to the x. You see why? Because if you let u equal to, this is 2 to the x, right? And this is 2 to 2x. 2 to 2x is the same thing as 2 to the x. Everything squared. Multiply the exponent, all right? This becomes u squared. So if you let u equal to 2 to the x, this problem becomes u squared minus 4u equal to 21. Okay? Let me write in here, make sure that you guys see it. 2 to the 2x equal to 2 to the x squared, which is u squared. And then you see a quadratic. You want to solve a quadratic, bring everything to one side, have 0 on the other side. So you have u squared minus 4u minus 21 equal to 0. Trifactor, if it doesn't work, then quadratic formula. 4, 21, 7, 3. Yes, should work. So u minus 7 times u plus 3 equal to 0. So we have u minus 7 equal to 0, or u plus 3 equal to 0. You got u equal to 7, or u equal to negative 3. Now, take a look. You let u equal to 2 to the x. This will always be a positive number. Okay? Let u equal to this. So u will always be a positive number. This won't work. This one is okay. So u equals 7 is okay. So 2 to the x equal to 7. Now you have to solve for x because u is just yourself. So how do you solve for x from here? X on the exponent. Plot the log on both sides. X, ln of 7. X ln of 2 equal to ln of 7, or x equal to ln of 7 over ln of 2. And that will be the solution. Okay. So the technique for this type of problem is you're going to do a use up. And you have to look at the problem carefully and see if they have the same base before you can do the use up. So let me show you another example. Again, solve for x. This time we have this. 9 to the x minus 6 times 3 to the x plus 8 equals 0. In this problem, this is base 9 to the x. This one is base 3 to the x. Even though they are not the same base yet. But I claim that we can modify this number 9 right here and make it look like the same base as 3, because you all know that 9 is actually 3 squared. So this is no more than 3 squared to the x, so 3 to the 2x, minus 6 times 3 to the x plus 8 equal to 0. And this problem brought back to the previous one. You let u this time equal to 3 to the x. Of course, u is positive, because 3 raised to whatever exponent is going to be a positive number. And 3 to the 2x is going to be equal to u squared. So you have u squared minus 6u plus 8 equal to 0. And factor out, does that work? Yeah. U minus 2, u minus 4, yes, equal to 0. So you have u minus 2 equal to 0, or u minus 4 equal to 0, or u equal to 2, or u equal to 4. Now, both solutions are positive, so you're going to take them both. This means, and keep in mind you are starting for x, okay? So 3 to the x equal to 2, or 3 to the x equal to 4. And this means x ln of 3 equal to ln of 2. So x equal to ln of 2 over ln of 3. This means x ln of 3 equal to ln of 4, or x equal to ln of 4 over ln of 3. And you guys have two solutions in this one. And this examples wrap up the video clip today. Hopefully via a couple of examples I'm giving you, this give you a good hint of how to work with logarithmic and exponential equations. As usual, please don't hesitate to ask should you have any question. Thank you for watching. Have a good day.